Hi, my name is Sabri. I lead the R&D department at Uranova in Belgium. And today we are going to talk about the challenges of deploying machine learning models in production. First, let me introduce you our company, Uranova. We want to have a positive impact on the world, and we believe that technology is the best way to achieve that. And we believe in creating new knowledge is the best way to see further and to pave the way towards the objective. And that's why we have three missions. First, to explore the most promising IT technology and to create knowledge. The second mission is to craft products out of this technology, bringing value to our customer. And finally, to serve our customer and to bring this knowledge to the industry. And that's why we are organized into three departments. A data consulting department, where we have implemented more than 100 use cases in media, pharma, HR, banking, automotive, retail, you name it. We have an R&D department, where so far we have more than 37 scientific publications in international conferences. And in between, we have our product factory, where we can integrate knowledge and business needs from the industry. And Digazu, our data hub, is one of the first release of this software factory. Our R&D department works a bit like a research lab in academia. Actually, we use the same mechanics as an academic lab, but on topic having an impact within 2-3 years on the market. And that's why today we have a list of really strong partnership here with existing universities. And we are always looking for new partnerships. So if you're interested into collaborating on master thesis, internship, PhD, paper writing, sponsoring, research projects, anything, just contact us and I will be glad to start discussing with you. Let's talk about the topic of today now, setting machine learning models in production. If you look at the typical life cycle of machine learning projects, well, it looks like simple. First, as soon as the data are available, you can just look at the data you are looking for the specific use case you're working on. You select the data, you import this data in your data science workbench. You build your model, you test it, you validate it. You build the data pipeline that will feed the model in production. And finally, you deploy the pipeline and the models. So it looks quite simple. However, in real life, it's not so easy. And you have really huge challenges to face. And here, my aim here is not to list all the possible challenges you are going to face, but rather to share with you the most important one we have met during the last 5 years in data-driven projects. First one, the fact that data are disseminated across the enterprise. 2, data and legal compliance. 3, complexity of the tech stack. And you will see that this one is really a big one. And ML ops. I will go into detail in the next section about each of them. But before going to detail, let me first introduce you the impact of these challenges. The impact for the market, for the industry. The first noticeable impact is on the price. The fact that today, the simplest use case, the smallest use case, which is AI or machine learning driven, costs today between 500,000 and 1 million euro. Why? Because of the complexity and all these challenges. I will explain you why just after. The fact that this complexity makes it very complicated to be compliant, and the cost today for the compliancy, especially to GDPR, is really huge for enterprises. And the skills. Of course, this complexity needs to have skilled people. The EU Commission released a report last year and expect that next year in Europe, we are going to lack about 700,000 skilled people in data science and data engineering. So the impact of these challenges is quite important. However, solution exists. And as I will explain you now in the next slide, for each challenge, there are some solutions. So let's have a deeper look on these challenges. First, disseminated data. When you're a data scientist and when you start working on a data-driven use case, well, the data you need are hardly often on one single place. Usually you need to look at the data where they are, and it could be anywhere. They are spread in different locations. In addition, they are copied multiple times, and you don't know whether when there is an update, if this update is correctly propagated on all the different copies and replicas. In addition, you usually don't know who is the master data, who is the data that should be then uniquely updated. You usually don't know that. Some data could be batch, some data could be real time. It's up to you to integrate both of them. And you need to check the consistency and the quality of the data. Can you imagine if you need to do that yourself just before every single data-driven use case? That's a lot. Hopefully, there are solutions. And the two main solutions for this is data architecture in one hand and data governance in the other hand. Data architecture. Well, in data architecture, we have a few patterns that help you to organize this data and to either centralize or distribute the data correctly. You have the data lake and data hub pattern. In this pattern, you can collect, store, historize, distribute data among all the data consumer within the enterprise. You also have the data mesh. Data mesh is very interesting. It's a way to apply domain-driven design to data architecture, and that enable to share your data across different domains in a really easy way. So from an architecture point of view, we have solutions, but you need to put them in place. And the second aspect to resolve this is data governance. And to be accurate is actually information management. It's the management of all information through its life cycle from data acquisition to archiving or deletion. And you will see that it's a really mandatory aspect to put in place. On challenge 2, you have the data and legal compliance. Of course, you know GDPR that covers and regulates data acquisition, data storage, data processing, data access management, deletion, retention period. Well, there is a lot of things that GDPR covers. But you also have the domain regulation. In finance, you have Sarbanes-Oxley, for instance, in US. You have the MiFID. You have PSD2 for the open banking API. You have safety and trial regulation in pharma. Well, each domain will have this specific compliance and legal aspects. What does it mean for you as a data scientist? Well, it defines what data you can use and how you can use them. And it's never easy to know for a complete data set from which data comes from different parts of the company with different legal base for the acquisition, how you can use and which data you can really use. Well, for doing that, I would suggest a three-way approach. First, still data governance. You will see that data governance will come back as a recurrent solution because it's really important. And there, data governance will enable you to track the data lineage, the different lineage of which process what data and how. And having this graph of process applied on data. This will help you actually to trace back any kind of process and to be sure that the processing you apply is correct. You will have to develop an enterprise data model and the associated business term into business catalog. Why? Because you will be able to qualify the data. You will be able to define that this data is a privacy data, this data is a credit card data, this data is a financial data. And once you have qualified it, it will be much easier to define the access policy management on this data. Step 2 is information management process. You need to put in place role, responsibilities, and processes. Data steward, data owner. When I'm a data consumer, what is the process for onboarding a new data consumer? What will be the process for validating from my data privacy office that I have the right to see this data? It's all the process management. And step 3 is anonymization. And that's still an active field of research, and especially about privacy preserving processing. Processing that is able to, well, anonymize the data and still keeping the distribution of the data quite close to what it was at the beginning. It's a very interesting field of research, and there is still some solution in the market like differential privacy or key anonymity. The challenge 3 is about the complexity of the tech stack. And that's actually really amazing to see the number of technologies you need to master today if you want to deal with data. It could be in data infrastructure, in data management, data science. Well, the number of technology is just amazing. And today, in between a business need and between your data, well, you are asking people, data scientists or data engineer, to master them. And well, that's usually a source of complexity. The fact that you have a lack of qualified and skilled resources in all these technologies, the complexity of the software to implement, the fact that your data pipeline that is going to feed your machine learning algorithm is actually composed by different framework, and the complexity of the optimization for this framework and this pipeline is becoming very complex. And that's one of the reasons why the price today for a simple data-driven use case is around 500,000 and 1 million euro. My first advice is, well, first you need to define architecture patterns and technical architecture patterns. You need to have people understanding the full stack, understanding your objective and your strategy in terms of data science, and some people understanding the in and out of this kind of new technology like Ray or Robot or Dask. Let me give you an example. You have today on the market, you see something like Ray and Robot on the market. So Ray enabled to distribute and integrate framework like Keras, TensorFlow, PyTorch, MXNet, and so on. And Robot does the same on TensorFlow. So who can today decide, well, for my specific enterprise, it will be better if we deploy Ray and the Ray ecosystem with Tune and Airlib for the reinforcement learning, and Panda on Modin, having Pandas on Ray using Modin. Or it's better to use Robot with TensorFlow. And by the way, for Pandas, we are going to use Pandas on Dask with Modin. So you see the implication, the pros and cons is actually very complicated to set up. And you need some people capable to analyze your need and to define what will be the correct tech stack to put in place. So the first advice is first scope your technical stack. You need to govern the number of technology you are going to deploy. And I completely agree, it's a trade-off between a constrained catalog, locked catalog, and the freedom of you data scientists to come with any kind of new technology you want. And that's an issue because it's a real trade-off between innovation and proactivity. You as a data scientist, you want to come with a new tech in production, and the fact that, well, for costs and running costs and for the governance of the technology stack, we need to limit to the catalog. However, create a sandbox where data scientists can play. And that will be interesting because there they can play with any kind of tool they want, but we need to have a production strategy for every new technology. And the technical architecture I was talking about in the previous slide will help you actually to avoid writing any kind of Python prototype in Spark for production. I've seen this so many times. The fact that rewriting code costs a lot. And if from the beginning you can avoid this by having clear technical architecture guidelines, it would be great. And finally, use auto-tuning framework as much as you can. Today on the market, we have auto-tuning framework for the infrastructure from framework, things like parameter tuning, application performance management can give you very useful automatic configuration. And in machine learning, of course, you have things like hyperparameter optimization, AutoML, and network architecture search that can automate a lot of things in the modeling phase. Don't hesitate to use them. And the last challenge is about ML ops, operating machine learning in production. You know, today machine learning models are actually piece of code, but with really specific things. So you can bring a lot of good practice coming from the DevOps domain and apply them on the specific things of your machine learning model. So for instance, on the lifecycle management, the version control of your model, the experiment management, the fact that you can launch different experiments on different data sets with different parameters, how you're going to trace back all different experiments, the result with the right parameter on which data sets. That, for instance, enables you to guarantee that the model that runs now in production has been validated on this dataset with this parameter with such accuracy. Production readiness, that's really interesting. That's a really interesting topic. Let's imagine that now you are doing a prototype for detecting the hand on a steering wheel of a car. And you have a prototype that has been trained on simulation video, and that works quite well. And now you would like to deploy this in production to equip every car in the world with this image processing algorithm. But how can you be sure that now the hand detection on the steering wheel will work with glove on the hand, will work when people will have, I don't know, a cigarette or a coffee mug or just a cat on the knee? How can you be sure that your algorithm is robust enough? And robustness is a very interesting field of research here, because if you need to go in production, you need to be robust of what you are going to see in the wild. Deployment and environment, the fact that you can automate the deployment of your machine learning model, automate the deployment of the data pipelines for feeding this model, deploying the serving model if you need, the API server, everything in DevOps and automation are really important here. And finally, control and monitoring, the fact that usually your machine learning model is trained on data having a specific distribution. Of course, I'm not talking here about online learning and reinforcement learning, but most of the machine learning models are trained on data set having a specific distribution. How can you track the fact that the data as an input of your algorithm has the right distribution? And can you detect if you have a change of distribution for triggering a new training of your model? Can you do that directly from your ML apps? Well, today on the market, some framework arrive. You have actually, I have a few here: MLflow, Kubeflow, ModelChimp, Datmo, CML, Allegro Trains. All of them are providing very interesting feature for managing the entire lifecycle management of your model and the deployment in production. Advice 2, well, integrate with your data factory. Coming back to the challenge 1 and the data hub concept, well, the integration with the data pipeline here will be key if you would like to simplify the deployment of your model. And if it is not provided by these kind of tools, just plan to have integration with monitoring tools here. So the contribution our company has in this domain is by twofold. From the industry point of view, we have a product, Digazu, which help then making the data available, integrating in data science workbench with Kubeflow, building data pipelines, deployment in production. So this is handled by Digazu. And we have research tracks that focus on data privacy, auto-tuning of framework, data pipeline optimization, and data quality control. I will not spend time here in this slide. Data privacy is about NLP and ontology in first-order logic. Automation here is about AutoML, especially in multi-modalities settings. Data pipeline here is especially about reinforcement learning and continuous improvement of the optimization configuration of the pipeline. And data quality is mainly about generative approach like GAN for missing data and relationship constraints between datasets. Conclusion, well, for these 4 challenges, the key element to consider is first, data governance and information management. This is really key. Data architecture and the technical architecture definition. This is really mandatory if you would like to control your tech stack and govern and automate as far as you can the machine learning model lifecycle. And of course, beside of that, you still need to have talented people like you for the modeling phase, of course. Before closing, let me just add one slide that we are hiring. So if you're interested into one of these profiles, don't hesitate to send us your application. And we are organizing a workshop about real-time stream analytics, CEP, and stream data management in big data, co-located with IEEE Big Data. So if you're interested, don't hesitate to submit your paper. The deadline is for October 1st. Thank you.